Welcome back to Maths Made Easy Suresh. I'm absolutely thrilled you're tuning into this explainer because today we're zeroing in on a date that is literally legendary in the math world, May 29th. You know, it's wild, but every single mathematician we're going to talk about today was either born or died on this exact date. And trust me, their work, it touches almost everything you do.
So let me ask you a quick question. What do your smartphone's GPS, Google Maps, the crazy realistic graphics in your favorite 3D video games, and, even the Wi-Fi you're probably using right now, what do they all have in common? I mean, we use this stuff every single day, right? Well, the hidden logic, the precise physics, and the geometry powering all of this modern tech, it was all unlocked by brilliant minds connected to this one single date, May 29th.
Just look at how these massive historical moments overlap. In 1914 and 1919, we've got math and astronomy teaming up to literally redefine our view of the universe during solar eclipses, putting relativity to the ultimate test. And then, jump to 1935, we get a major breakthrough in combinatorial geometry with the, honestly, perfectly named happy ending problem. These aren't just random dates on a timeline. These are flashpoints where human curiosity totally shifted our reality.
All right, let's jump right into our first pioneer, Erwin Finlay-Freundlich, born on May 29, 1885.
Okay, let's dive into this. Freundlich actually started out studying naval architecture. But lucky for us, he took a hard pivot into astronomy and ended up helping prove Albert Einstein right. So back in 1911, Einstein is working out his general theory of relativity, right? But he desperately needs actual physical proof. Enter Freundlich. He stepped up and did the incredibly daring, complex math needed to measure Mercury's orbit and the deflection of starlight. And why does this matter for you and me? Because that exact physics of relativity that Freundlich proved, that's the precise math that keeps your smartphone GPS perfectly accurate today. Seriously, without his rigorous number crunching, your digital maps would be miles off.
And you don't just have to take my word for how critical this was. Look at what Einstein himself said. He called Freundlich the first among fellow scientists who has taken pains to put the theory to the test. Think about that. Even the absolute greatest genius of the 20th century relied on Freundlich's practical, rigorous astronomical math to prove his mind-bending theories to the rest of the world.
Transitioning way back to the 17th century now, we meet Frans van Schooten, who passed away on May 29, 1660.
Growing up in the Netherlands, surrounded by both art and math, Van Schooten essentially became the godfather of computer graphics. He took René Descartes' really complex and, let's be honest, sometimes pretty obscure ideas blending algebra and geometry, and he brought them to the masses. He translated them, expanded on them, and taught the world how to turn pure algebra into visual graphs. So if you've ever been blown away by the graphics in a modern 3D video game, or just appreciated the crisp layout of your digital screen, you are literally looking at the direct descendants of his 17th century math.
And this brilliantly illustrates the whole point. Every single curve, every pixel, every 3D shape rendering on a screen right now is built on the geometry he helped give the world. It is absolutely wild to think that pure math developed in the 1600s is the invisible engine driving your favorite modern video games today.
Moving fast forward into the 20th century, we have George Szekeres, born on May 29, 1911 in Hungary.
Now, his family really pressured him to get a degree in chemical engineering, but Szekeres' true love? Pure math. He became a total master of networks, making these massive foundational contributions to combinatorial geometry and graph theory. His rigorous mathematics is literally the hidden logic that routes data seamlessly across the internet. Whenever your phone connects to Wi-Fi, or you open up a social network to see how you're linked to friends across the globe, you're relying on the exact type of graph theory Szekeres helped pioneer.
And guys, there's such a beautiful human story behind this math. In 1935, Szekeres was working on this geometric puzzle, proving that among any 5 points in a plane, where no 3 line up straight, 4 of them will always form a convex quadrilateral. Another mathematician, Paul Erdos, dubbed it the happy ending problem. Why? Because working on this exact puzzle led Szekeres to marry Esther Klein, the brilliant mathematician who actually proposed the problem in the first place. They tied the knot in 1937, managed to escape war-torn Europe, and settled down in Australia where they kept publishing math together for decades.
Ultimately, his math does something kind of beautiful. It finds hidden patterns in a chaotic world, proving that even totally random networks have beautiful connections. Szekeres showed us that deep mathematical order always emerges from chaos. You just kind of have to know how to look for it.
All right, finally, let's meet our last pioneer of the day, Charles Loewner, born on May 29, 1893.
Loewner's story is one of sheer resilience. He fled Nazi occupation and arrived in America totally penniless. Seriously, he was teaching advanced math in a local brewery early in the mornings before eventually rising up to become a true pioneer of fluid dynamics. So the crucial point is, during the 1940s, his incredibly deep, theoretical math dealing with critical subsonic flows gave engineers the key to understanding aerodynamics. That mathematical foundation, that is exactly what shaped how modern jets fly and how engineers design those ridiculously fast aerodynamic cars we have today.
The beauty of his mathematical curiosity is captured so perfectly by a fellow mathematician who said, "Both the problem posed and the answer given are totally unexpected, of importance for electrical engineering and for quantum physics." It just proves that true mathematical exploration almost always leads to world-changing real-world applications, usually in ways literally no one saw coming. Which brings us to our final thought for today. These May 29th pioneers, Finlay, van Schooten, Szekeres, and Loewner, they looked at the stars, they looked at shapes, they looked at networks, and they fundamentally changed our world. They gave us the foundation for GPS, computer graphics, the internet, modern aviation, the whole shebang. So my question to you is, what hidden patterns will you discover in the chaos of tomorrow's technology? If you had fun unpacking the math behind your everyday life in this explainer, definitely smash that like button. And hey, make sure to subscribe to Maths Made Easy Suresh right now so you don't miss our next deep dive into the awesome history of mathematics. Keep exploring, keep asking questions,